Hi, today we are seeing about the topic of applications of a diode. Applications of diode. Basically, diodes are applications are clippers, clampers, and rectifiers. So we see the first topic is what is a clipper, what is the circuit diagram of clipper, how it works, and where these clippers are using generally. We will see about the total topic of a clipper. Now see the first, what is a clipper? So the clipper is a circuit. First we will draw the circuit diagram of a clipper. Circuit diagram, circuit diagram of a clipper. How it is? Basically it is a diode, and diode have one resistor, and this is the input supply Vi, and this is output V0. This is the circuit diagram of a clipper. This is the diode and this is the resistance R. Here what is a clipper? Means the circuit with which the waveform is shaped by removing the portion of the input signal. For example, we will see we have a signal, sinusoidal signal means AC signal. Here we give here Vi, that means AC signal, right? This is V and this is time. So Vi, basic sinusoidal signal. What is a clip? Clip means some part, either positive or negative half of the cycle is elimination. That is a clip, basically a clip. So the circuit with which the waveform is shaped by removing or clipping some portion of the input signal without distorting the remaining part of the alternating wave is called a clipper. The circuit is without disturbance the another wave and clip the half of the signal. Basically these clippers are four types. Those are positive clipper and negative clipper, biased clipper and combination clipper. These four general categories we are used in a clipper. And these clipping circuits, any clipping circuits basically have one diode and one resistor. And in this positive clipper or negative clipper, whatever these clippers also, one is a series clipper, one is the series positive and one is a shunt positive. Means this diode and resistor, these both are connected in one case series connection and one in the shunt connection. So we will see what is the further details. Okay, here practically this R resistor, this resistance is there na. This resistance have the some limit current flow through the diode when it is a forward biased. At the same time, this output waveform of the clipping level, the value of R, this value of R is satisfies the some conditions. What those are? Every forward bias, in case of resistance, the forward bias positive resistance, in negative bias, reverse bias, it is a reverse resistance, and commonly one resistance is there. So this have the one, it satisfies some condition, that is RF is less than R and less than RR. That means so R is equal to square root of RF and RR. So RF is here forward resistance and RR is the reverse resistance of a diode. This is the common R of the diode. This condition must satisfy the clipping circuit. So here we already discussed those types: positive, negative, biased clipper and combination clipper. So now first we will see the positive clipper. Positive clipper. What is a positive clipper and how this positive part, how it is clip the portion. In positive clipper also, I already told you, one series and one shunt clippers, shunt connections are there. In a series positive clipper, here what I draw, this is the series positive clipper. In a series positive clipper, when input voltage is positive, the diode does not conduct and act as a open circuit. Here diode, this is the negative and positive now, so we are giving this positive to diode, so diode is does not conduct, so this is a open switch. In this condition, in the open circuit, so positive half cycle does not appear. In a waveform, what happens, we already see, this is our waveform T V. Diode is negative, so it is not open, so positive half cycle will not appear, it is a 0. Next, when the input signal is negative, the diode conducts and acts as a closed switch. It's a closed switch means negative half cycle appear at the output at the same. So this is called clipping, positive clipper. Positive clipper is half of the circuit, means positive signal is clip and negative signal will same. How it is in a input signal, that will appear at the output signal. This is the V0 and this is the Vi. In a shunt positive clipper also same. Input diode, here in shunt positive clipper, circuit diagram is little bit different will come. Means a shunt means what happened, this resistor is here and this diode is occurred at here. Input voltage is positive, so diode act as a short circuit, so 0 signal, and positive signal is clipped off. At the same will occur in the positive shunt clipper. This is the positive series and positive shunt clipper. Output is the this only. Input signal is the sinusoidal and output is positive. Half of the signal is clipped and the negative half cycle will appear at the same of a positive cycle. So these positive clippers we are calling as a half wave rectifiers. Means in case of half wave rectifiers, what happened, half of the signal will distort, means clipping, and half of the signal will appear. So this is related to half wave rectifier, not a fully. This is a positive clipper. Next we will see negative clipper. In case of negative clipper also same, the circuit is same as usual, diode, but the here one small difference is there. In positive clipper, diode is negative one direction, diode is a positive here, and the same resistance Vi, and this is called as V0. Here see positive minus positive, and this is the resistance. In case of positive clipper, diode is in reverse, here the positive side. So now same discussion, diode is connected to the same direction, means same direction. So series negative clipper, during the positive half cycle, input signal of the diode conducts and acts as a short circuit. So positive half cycle of the input will appear. In a same negative half cycle, here in a positive clipper, what will happen, this is the same our sinusoidal waveform, means input waveform Vi, and output will be positive will appear. So first half of the positive half cycle will appear, positive half cycle will appear, and the negative half cycle means the negative of the diode is open circuit. So here the voltage and will be 0. So half of the cycle, positive half cycle only appear, and the negative half cycle will be clipped off. In the same negative shunt clipper also. This is called a perfect half wave rectifier. This is a correct perfect half wave rectifier. Next we will see about the now what we see, positive clipper and negative clipper, and the third one is the biased clipper. In biased clipper also more types are there: biased positive clipper, biased negative clipper, and biased reverse polarity of battery, positive reverse polarity and negative reverse polarity. These also again most types are there. These biased clippers are small portion of the positive negative half cycles of signal. Here half of the waveform will distorted, means it will clip off. In case of biased clippers, so here we are using external another voltage source like this, same diode and resistor, but here we will give the some external voltage source, same Vi and V0 diode resistance, and this is VR. Okay, one resistor we are giving here. In a biased clipper, anything in as a biased clipper, these four conditions are there. I already told you, na, positive, negative and reverse polarities of these voltage source. In biased clipper, diode not conducted. Here some conditions are there. Vi input voltage is greater than VR. This Vi is greater than VR, then diode is not conducted, so output is raised up to VR. That means here I am giving a waveform. Vi, and the output will be V0, and at some particular condition VR is there. Here we are giving the voltage source, so VR is there. So what will happen at VR? Vi is greater than VR. Up to that condition, the input voltage is same, means like this. Here also VR is there up to here, so VR is there. When up to here, diode will, means signal waveform is not clipped. After the when it will reach Vi is equal to VR, in this condition it is clipped, and again it will fall down, and again output voltage is same, so this part will be clipped. So this is the use of biased clipper. Only half, some portion only we will clipped in this condition. And the same when Vin is less than VR, diode is not conduct. So diode is not conduct. It is a short circuit. So positive cycle is clip some part and negative circle remain same. Because diode negative, in last time we have seen a diode negative is giving to the negative only. So diode will open circuit. So diode is in same. Waveform will not shift. What is input and output will be same appear. This is the biased clipper. Next we will see the fourth one. What that is the combination clipper. Fourth one is combination clipper. Combination clipper. So here same, in combination clipper means we are combine of two clippers, one positive clipper and one is the negative clipper. The circuit diagram of a combination clipper is one resistor is there and one diode D1 and one is the voltage source, and here another diode, it is reverse of the direction diode, and negative positive. Okay. This is Vi and this is V0, resistor D1 D2, voltage VR1 and VR2, plus minus minus plus. This is circuit diagram of a combination clipper. Now we will see the waveforms. what is the input and how output will come. Same as usual, our input signal means T, and this is the input signal Vi. Same here, it is someplace VR1 and here VR2. This is the positive and negative. Why we give here minus, negative VR and positive VR1, that's why we give. So now we will see the what is the conditions. In a combination clipper, when input signal voltage, same condition like a biased clipper, Vi is greater than or equal to VR1. This is the first condition. Vi is greater than or equal to VR1. Diode D1 will conduct. Diode D1 conducts and acts as a closed switch. So see, up to here diode will conduct, and after this Vi is greater than or equal to VR1. After this diode is not conducted, means it is like this, and this part will be clipped. And now same condition, second condition, while diode D2 is in reverse bias, D2 act as a open switch. Hence the output voltage is not exceed the level of VR1. So during the first positive half cycle, and the input voltage is Vi is less than or equal to VR2, means minus VR2. Sorry, here this is the minus VR2, right? Minus VR2. In this condition, diode D2 is not diode D2 will conduct and act as a closed switch. In this time, diode D1 is not conduct and it is a like a open switch. So here diode D2 will conduct and it will appear in a negative switch. So again, up to some condition, means here maybe minus VR2 will be there. Up to here, diode will work, and here it will clip. Again wave will be flow. So this is the clip. Again same, and it clip, and again. This is the combination clipper. It is evident that clipping levels may be changed by varying the values of these VR1 and VR2. These values will be changed, so the clipping levels will be changed. If VR1 is equal to VR2, the circuit will clip both both positive and negative half cycles at the same voltage. Such a combination clipper is called as symmetrical clipper when that condition VR1 is equal to VR2. This condition, when it will satisfy, this is called symmetrical clipper. Means combination clipper will also call symmetrical clipper. In next class, we will see about the other application, clampers and rectifiers. Thank you. If you understand this topic, please like and subscribe my channel and press bell icon for further notifications.